Hello everyone, our today's topic is ballistic protective clothing. So, first we will try to understand what is ballistic protection, then we will see different parameters which affect the ballistic protective performance of clothing and what are the latest trend in developing the ballistic protective clothing. Ballistic protection means basically one aspect is that impact resistance, its ability of any material to withstand failure due to stress applied at high rate. So, in ballistic material they always impact the material at very high rate of at a very high velocity, and that stress is applied at very high rate. So, it is a desirable property in many textile applications. These applications are basically body armors, mountaineering applications, mountaineering rope, parachutes. So, in all these applications apart from many other applications, sudden impact force is being applied, and this impact force is applied at very high rate of stress. So, ballistic protective textiles or ballistic protection, their threats are classified based on kinetic energy density KED. At different level of kinetic energy density, the threats are classified, like threats due to knife where velocity is typically 10 meter per second, and there are two types of knife threads from knife. If it is from blunt knife, that is kinetic energy density will be around 17 joule per square millimeter, and if it is sharp it can go up to 210. So, special textiles or plates are used depending on the thread. For handgun, the velocity is around 450 meter per second, and the kinetic energy density initially it is 16, and after penetration finally it is 4. So, special textiles are used. Assault rifle like AK-47 where speed is around 720 meter per second, kinetic energy density is 45, and composites are generally used in this type of thread. For high velocity bullets SA-8 where velocity is 940 meter per second, kinetic energy density is 75 joule per square millimeter, where we need that ceramic armors are used. The main problem with the ceramic armors or composite is their weight. So, we need bulletproof vest with lighter weight for our protection. So, bulletproof vest is a protective clothing that can be made from different materials that absorb the impact of projectile fired from weapon. So, basically the bulletproof vest, its function is to absorb the shock, not to reflect. If we try to reflect, then the impact will be on the body of the wearer. Instead, if it absorbs, the shock will be dissipated around larger area. So, bulletproof vest can be prepared from steel depending on the threads, ceramics, polyethylene or Kevlar. As I have already mentioned, the bulletproof vest do not deflect bullets, instead it catches bullet and spread its force over a larger portion of the body. First, let us see how the body armors evolved. If we see the history, the people have protected themselves from injury with different types of material. In the early days, that is in Stone Age, people used to use animal skin as barrier to injury and attack. So, earlier days, so animal skins were used. So, as we keep on civilizing ourselves, the weapons we use becoming more and more advanced and life threatening. So, looking at those advancements, the animal skins were not enough. So, the next generation armor are wooden shields to defeat different threats, but main problem of wooden shields were they were not flexible and the weight wise it is heavier. So, it is not that convenient. In the 16th century, it was experimented in maybe Italy and Roman royalty with the idea of bulletproof vest. They built body armor with layers of metals, those were meant for deflecting the bullets. So, earlier days the body armors were actually idea was to deflect the bullets with the layers of metals. The outer layer was designed to absorb the bullets impact, while the inner layer was added to stop further penetration. However, metal body armor was largely ineffective against firearm. So, as we are becoming more civilized, the threats are becoming more severe. So, therefore, the challenges lie in the developing a material which will provide higher impact resistance while maintaining the weight of the assembly at the acceptable limit. So, as threat increases, we have to protect ourselves, but at the same time we should take care of that fact that it should not be very heavy, otherwise the extra weight will affect the performance of the wearer. In modern days body armors, we can divide into two categories, one is hard body armor, another is soft body armor. Says that it is hard, here metals or ceramic plates are inserted within the fabric structure. So, there will be fabric structure where metal or ceramic plates are inserted. So, due to these metals or ceramic plates, they are rigid, they are heavy, and these metals and ceramic plates they are used for high risk region by military officers and their protection against high velocity projectiles. So, as they are made of metal and ceramics, they are heavy. So, this is the main disadvantage of this hard body armor. They are not flexible and they are heavy in weight. That is why they restrict the movement of body parts. Ideally, there should have been flexibility, but the hard body armor that restricts the body part movement. On the other hand, the soft body armor, the idea was initially to enhance the flexibility with lighter weight. The soft body armors were actually are prepared using multi-layered woven fabrics or laminated fabric structure. They are more flexible than hard body armor, lighter in weight, and they are used for routine wear of police officers and security person, where the movement is very high, frequent movement is required, but relatively threat is less. In those applications we can use soft body armors made of multi-layer woven cloth. So, this soft body armors are effective for protection against low velocity projectiles, but main disadvantage here, although we are trying to produce the flexible soft body armor, but at least we have to use 20 to 30 layers of fabrics to provide sufficient protection. So, after adding 20 to 30 layers of fabrics, they become again inflexible in nature, and this soft body armors can only be used for low velocity impacts where threats are less. In soft body armor, impact resistance depend upon the fibers, yarns and fabrics used in that fabric, that in that different layers. Multi-layered Kevlars are generally used. The woven fabric made of Kevlar fiber is used in multi-layered fashion. Due to large number of fabric layers, the structure becomes again heavy and thick and they become inflexible. So, again this multi-layer fabric become uncomfortable to use, but to have sufficient protection we need a large number of layers, but the present day's research is in the area to reduce the number of layers and to reduce the mass of the overall body armor, keeping the protection level same or to improve the protection level. So, when we compare both hard armor and soft armor, in short it is rigid, it is more flexible, heavy, it is lighter, fabric structure combined with steel or ceramic plates. Here in soft body armor we use only fabric structure and that too multi-layered woven or laminated fabric structure. Hard body armors are used for military officers in high risk region, and soft body armor used for routine wear of police officer or security person. Hard body armors are used for projectiles with high velocity and soft body armors are used for low velocity. As of date, so soft body armor we can use for low velocity projectiles. So, main requirements of the body armors is that better impact energy dissipation. So, it should dissipate the impact energy, so that the impact does not reach to the wearer's body. The body armor should be of lower in mass and flexibility should be there. So, the target should be the weight reduction and flexibility improvement. Now, here if we see with the time, the aerial density is reducing gradually of body armors, and the research direction is that to reduce this mass further, so that it is very commonly used, and the person's protection is high, and due to the flexibility the performance, other performance will be better. But with all these changes it goes with enhanced cost. So, as we try to decrease the weight, the cost is also increasing. So, glass composite, aramid composite and ultra high molecular weight polyethylene composites. So, these are actually, this trend is to reduce the weight. So, how this soft body armors evolved? Soft body armor means with the flexibility. The first generation soft body armors were prepared from the silk by Japanese people. So, this type of body armors were used up to First World War with the silk, made of silk, and there the velocity protection, that they are very good protection against the low speed impact around 121 meter per second. But once the projectile speed has increased due to increase in threat, they could not give the sufficient protection. So, around 180 meter per second they fail. So, then people started thinking of next generation that body armor. The next generation body armor was prepared from nylon flake, which is inserted into the inside the jacket, and that is known as the flake jacket. They were used during Second World War. They are better than first generation jackets, because these flakes were able to both reduce the velocity of impactor and dissipate the energy. The main disadvantage of this nylon flakes or flake jackets were they are heavy and they could not give any protection against most of the pistol and rifles. When these pistols and rifles were developed at higher speed, they work on higher speed, due to this flake jackets failed. The third generation soft body armors were actually started after invention of Kevlar, which is para aramid fiber. It is developed around 1960s. So, after this development of Kevlar, we have started developing the soft body armor. It is very strong fiber, high impact resistance. However, 20 to 30 layers of Kevlar fabrics are required for sufficient protection. So, they again became heavy and inflexible, but still today the Kevlar is widely used for body armor application. It may not be soft body armor due to the 20 to 30 layers of fabrics, but still Kevlars are widely used for the soft body armors. So, therefore, the challenge lies in developing a material which will provide higher impact resistance while maintaining the weight of the assembly at acceptable level. That is the main challenge, and the scientists, they are working in these areas to reduce the weight, as I have already mentioned. So, the main requirements are better impact dissipation, weight reduction and flexibility improvement. So, the factors, if we try to see, which affect the impact performance are fiber and fabric related parameters, and second is the projectile related parameters. So, in fiber and fabric, there are different parameters. If we see the fibers used, mainly para aramid fibers are used, like Kevlar made of by the DuPont, Twaron by Teijing, PBO fibers are used, Xylon by Toyo, So, there are different types of high performance fibers used: ultra high molecular weight polyethylene, Dyneema is also used, so inorganic fibers like carbon, glass fibers are also used. Different fibers are used for this ballistic protective clothing. The important properties for this ballistic protective clothing, the fiber properties are: it should have high modulus, so that the extension is not high, it can absorb the high velocity impact. High tensile strength should be there, it should not break due to the impact. Low density, because we need to reduce the mass of the clothing, that is a ballistic protective clothing. Low elongation, because if it is its elongation is very high, then the bullet will simply penetrate, it should prevent the bullet. So, low elongation should be there. Good resilience, that means after impaction the structure should come back again. Low moisture retention, high thermal stability. High thermal stability is required in that fiber, because during the bullet penetration at high speed, the high heat generation is there. So, it should not melt or shrink or deform. So, high thermal stability is required, limited high limiting oxygen stability in extreme condition. Sometime it has been observed that at extreme heat or extreme cold condition, the fiber gets degraded or maybe it become brittle, it will lose its characteristics. So, this fiber property is extremely important, because this body armors are used in extreme conditions also. Now, as far as yarn characteristics is concerned, twist is very important characteristics. If we increase the yarn twist due to the obliquity effect, the yarn strength reduces. So, we must try to use the twist as low as possible. Breaking extension increases with the increase in twist level. So, as the twist angle increases, breaking extension increases, and also it reduces the modulus. So, you must keep the twist at lowest level, and if possible we can also use the zero twisted filament. Reduction rate is very high, reduction in modulus is very high at twist angle more than 5 degree. So, twist angle always at very low level, like less than 5 degree is recommended. As far as weave structure is concerned, there are different types of weave structures are used. 2-dimensional fabrics and 3-dimensional fabrics are used. The main idea of weave structure is that we have to use basically square fabrics, keeping the ends per inch and peaks per inch same, so that during impact both warp and weft they come into action, they perform equally. Basket weave is most commonly used. Apart from basket weave, the plain structure, twill and satins are also used. As far as 3-dimensional structures are concerned, angle interlock, warp interlock and orthogonal structures are used. Next parameter is that cover factor. Cover factor should be high, because if the cover factor of fabric is low, then the penetration probability of penetration of the projectile is high. So, cover factor range 0.6 to 0.95, within that range we must try to keep the cover factor. If the cover factor is more, very high, it is more than 0.95, the jamming condition will take place, which will if indirectly damage the yarn. So, once we try to enhance the cover factor, increase the cover factor, that means by keeping the yarns very close, warp yarn and weft yarn, particularly in warp yarn, if we try to keep the jamming condition during the weaving, the up and down motion of the thread, there will be rubbing against each other, yarn, the warp yarn. So, during this rubbing there will be damages of yarn, but on the other hand, if we try to keep cover factor less than 0.6, the fabric structure will be loose and projectile penetration will be easy. Next factor is the crimp. Crimp we should try to keep as low as possible, because higher crimp means the projectile resistance will reduce due to the straightening of the threads, and with the increase in crimp the transverse way deflection will increase and blunt trauma will increase. So, blunt trauma is the damages or impact during the penetration. Once the bullet does not penetrate, it has been arrested during the structure, but the level of impact it is subjecting at the back side, it is called blunt trauma. So, higher crimp means while the bullet is actually striking the fabric, there will be more deflection. I will show, this is a fabric with say yarn, straight yarn, there is no crimp. Another fabric with a crimp, higher crimp. So, once the bullet is striking, this is the bullet striking at high speed. So, there will be deflection, this deflection will be lower because the yarns are straightened and this will be absorbed by the straight yarns, but in case of higher crimp, once the bullet is striking, initially there will be straightening of the threads, straightening of the yarns will take place. So, initially the yarn is not taking the load. So, once the yarns get straightened, then the load will be shared by the yarn, and due to this deflection at the back other side there will be sufficient impact. This impact is known as blunt trauma. The bullets are not penetrating, but still the wearer is getting shock, higher shock. So, this blunt trauma is increasing with the increase in crimp. So, we must try to reduce the crimp level. Ideally the yarn crimp should not be there, so that the resistance is offered by the that yarn. Next parameter is the friction, which is very important in ballistic protection. Typically the friction should be around 0.2, more friction, more yarn that take place, because the at lower friction what will happen, the individual yarn will start sliding against each other, and the in case of lower yarn friction, the individual yarn pull out may take place. Now, let us see this is one yarn, the fabric made of yarn with lower friction. And here is another fabric made of higher friction. So, mu low, mu high. Now, suppose one bullet it is striking in the on this yarn. Due to low friction, yarn to yarn friction, this yarn will be pulled, this yarn will be pulled on the other side. So, if I draw the side view, so this individual yarn will be pulled out due to low friction. But here in this case, once the bullet is striking on this yarn, due to high friction, the other yarns will take part in absorption of the load, absorption of this energy or the bullet energy. So, this total wave will get dissipated. But on the other hand, this yarn will only take part in the absorption of energy. So, it will simply slide, it will simply pull out from the structure. So, yarn pull out force, that energy absorption more, but at very high friction the problem is that local stress concentration will be there, easy yarn breakage and energy absorption reduces. So, it should be high enough, but it should not be very high. At very high friction, that energy that the localization of stress will be there and easily the yarn will break. Instead, the ideal situation is that with small sliding, the energy get that total the force, the total stress should get dissipated among the large area. And last one is that the number of layers. As we increase the number of layers, the energy absorption becomes high. Here it is a impact of friction. This is the yarn with higher friction, the energy absorption, and this is the yarn with lower friction. So, for different level of impact velocity, the fabric made of higher friction yarn gives higher energy absorption. As far as number of layers are concerned, as we increase the number of layer, the ballistic limit increases. It is obvious that number of the more layers of fabrics are taking part. This picture also shows that the effect of number of layers on trauma dimension. As I was mentioning that the trauma, these are actually expressed in terms of depth and diameter of trauma. So, back face trauma. Now, this is the fabric from this side. Now, the bullet is actually striking, this is the bullet striking. After striking, the fabrics become, due to the deflection, so this is, and just after this fabric, this soft material is placed. This is some soft material, some clay or some similar material is placed. Now, there will be deflection in clay and this is the depth here, and this deflection, this is the trauma depth. Initially this was the thickness and here it has been deflected. This is the trauma deflection, this is a deflection of this surface, surface A, surface B, surface A, which is facing the bullet, and the diameter from this point to this point, this is the trauma diameter. So, if you see the front, if this is the area of deflection, so this is the trauma dimension. So, here if we can see here, as we increase the number of layers, the trauma dimension gradually reduces, and here it is a trauma diameter reduces and also the depth of trauma reduces gradually. So, projectile energy loss, we keep on increasing the layers. As we increase the layers, the projectile energy loss increases for different fabrics, woven Kevlar, woven nylon and knitted Kevlar. So, knitted gives less energy, projectile energy loss, woven Kevlar is giving highest energy absorbed by the fabric due to its high modulus and high strength value. Now, to select the fibers, particular fibers for ballistic protective clothing, we must understand few important parameters. Here the projectile is striking and there are two types of waves will be there. Along the striking direction there will be transverse wave on the fiber. This is a fiber, there will be transverse waves, and due to the stretch here there will be longitudinal wave front. So, transverse wave front and longitudinal wave front, and this wave formation, wave front velocity is extremely important just to know how quickly the impact energy will get dissipated. Now, the term C is the speed of longitudinal wave, and this is denoted by E by rho, where E is the under root E by rho, where E is the initial modulus and rho is the density of fiber. So, that means we need higher C means higher initial modulus, that means quickly the wave will get dissipated, the transverse that is longitudinal wave will get dissipated, and the fiber density should be as low as possible. So, to increase the value C, and one parameter which dimensionless parameter fiber property which has been developed to evaluate the protective performance of the impact protective performance of a particular fiber. So, the term U is given by sigma multiplied by epsilon divided by 2 into rho, where sigma is tensile strength of the fiber and tensile strain of the fiber and density of the fiber. So, this parameter is known as specific toughness and multiplied by the speed of longitudinal wave. So, this parameter U is a dimensionless parameter, and higher the U value, the better will be its impact resistance or that projectile, it can hold the projectile. So, higher impact behavior will be there. These are the general properties of some of the fibers used for ballistic protection, glass, aramid, polyethylene, then PBO. So, high molecular weight polyethylene like Spectra, Dynamia are used for this bulletproof fabric. PBO is also used, and from this if we get the knowing the property, we can calculate the U value, fiber property U value. So, these are the U values of different fibers used, where Kevlar is around 680, Spectra 802, Spider silk, these are the for future armor. So, the development in armors, body armors will be in this direction, where spider silk or different carbon nanotube composites are used. Apart from fiber and fabric characteristics, the projectile properties are also important. The projectile properties are first is projectile geometry. There are different types of projectile geometry shapes are available based on the tip dimension, that is the hemispherical, conical, fragmented and flat, whereas pointed bullet causes severe action, okay, that is conical. These are different shapes of projectile, and also projectiles performance is dependent on the dimension of projectile, the diameter. This is fragmented, flat one. Angle of impact is also important. So, low angle of impact means there will be sliding. Ideally, the angle of impact, if it is 90 degree, that will penetrate and there will be no sliding, only peripheral area is in contact with the body armor, no sliding will be there. And third one is impact velocity. So, higher the impact velocity, higher will be the energy absorbed, but if in case of very high velocity, immediately that those body armors it will penetrate inside, in that case it has been observed the impact energy is absorbed energy is reduced. So, to increase this absorbed energy, we have to first catch those bullets. If it penetrates, then absorption will again reduce. So, now coming to the evaluation of performance. So, ballistic evaluation techniques are dynamic impact test by weapon test. So, to measure the residual velocity, and by NIJ standard, National Institute of Justice standard, we follow, that is V50 measurement, and back face signature is also one of the ways to measure the ballistic evaluation. So, dynamic impact test is basically a laboratory method of testing, and if we take the other test, weapon test and NIJ test and back face signature test, they are not actual laboratory test, they are actual field test. So, dynamic impact test, here it is a one impact, dynamic impact tester is used, where heavy moving assemblies are there, it directly impacts on a flat surface with known dimension. Here the striker dimension is diameter is 13 millimeter, inner jaw diameter is 76 millimeter and outer jaw is 108 millimeter, and the Kevlar fabric is kept and striker is striking at certain speed. This is the photograph of one of the instruments, such instrument. Now, second is that weapon test, and here this weapon test is that there are 4 different screens available and the bullet is shot and this is a test sample. The 4 optical screens are used to measure the bullet velocity before and after impact. So, this here at different dimension, different distance, we measure the bullet speed, and even before impact and even after impact we measure the bullet speed at different distance. So, this is the picture photograph of this technique. Here is the specimen kept, and the energy absorption calculation is simple. Whatever kinetic energy is absorbed, that is half m v 1 square minus v r square v I square by minus v r square, energy absorbed E, m is the projectile mass and v I is impact velocity before striking and residual velocity after its coming out. Okay. In as per the NIJ standard, baseline limit test, that is V50, is performed on the actual armor and designed to statistically measure the penetration performance. The large number of bullets are shot on the armor and probability of penetration is measured, and V50 is the velocity at which the probability of penetration is 50%. So, typically minimum 50 for 12 shots are there per panel, including at least 5 should be partial penetration and 5 should be complete penetration. So, that is the requirement. If we take very high velocity where complete penetrations are there, then we will not be able to get the 50% probability. So, arithmetic mean of 10 velocities, 5 in complete penetration and 5 in partial penetration were taken. These are tested in dry condition, and clay backing materials are used to measure the back face signature. As I have already described, shots fired from fixed distance to the target, that is 5 meter for type 1, 2A, 2 and 3A armor, and 9 millimeter round nose bullets were used. These are used for type 1 to type 3A. This is the velocity for which probability of penetration is 0.5. This is the 0.5 probability. So, typically we increase the velocity and try to see the probability. So, here this velocity it is called V50 and that is measured, and position of shot as per NIJ standards at different places to calculate the V50, and as far as back face signature test, it is as per the again NIJ standard. BFS is measured, it is measure of blunt trauma experienced due to a non-perforating bullet. So, once it is perforating, then it is entering into the body, but for non-perforating bullet the blunt trauma is measured. This is a critical aspect of ballistic evaluation, as it determines the internal injury to vital organ during ballistic impact. It may damage our body without penetration. BFS is obtained by measuring the maximum depth of deformation of the armor panel impacted by non-perforating bullet on the back side of the material. So, the analysis of results should be done as per the NIJ standard. Now, there are different approaches to reduce bulk in soft body armor. As we have already mentioned, the soft body armor, the development should be in the area of reduction of thickness and increase in flexibility and reduction in mass. So, the approaches are a development of resin fabric composites the 3-dimensional woven fabric, we can use non-woven fabric as cushion layer, incorporation of carbon nanotube or nanofiber in the fabrics, and application of shear thickening fluid in fabric. So, these are the approaches one can try. The research are going on in these areas. The shear thickening fluid is a viscous material where with the increase in shear rate, the viscosity increase to a great extent. It acts as solid material. So, these are they have two phase concentration dispersion. One is solid phase, consists of nano or sub micron particle, and liquid phase which consists of a medium or carrier fluid in which particles are dispersed. So, they form a viscous liquid, and the mechanism is that the shear thickening is the property which shows the significant increase in viscosity above critical shear rate, that is in non-Newtonian flow takes place, which transforms the shear thickening fluid into a material which will act like a solid. Here this is at a certain speed velocity, initially the shear, that is viscosity reduces, but after certain critical level the viscosity increases. Here this molecules they act as the it is a solid. So, immediately the shear viscosity increases. So, if we apply this shear thickening fluid on fabric surface, when the bullet is impacted, this viscous liquid, viscous layer will act as solid barrier. So, initially at lower level of shearing, these are very flexible, but at higher shear rate during the bullet shot they become a solid, and the protection level increases to a great extent. So, STF treatment has been shown to improve impact resistance of Kevlar fabric. So, less layers can be incorporated. So, we can reduce the number of layers and increase the flexibility of the body armor. So, along with the improvement in flexibility, comfort also improve. So, that is all about the ballistic protective clothing. Thank you.